Hello, this is Jean-Paul Zhang. This course is Introduction to Data Structures. Today we will study Chapter 2, Data Design and Implementation. Data is defined as the representation of information in a manner suitable for communication or analysis by humans or machines, like computers or smartphone. They are the nouns of the programming world. The objects that are manipulated, the information that is processed. For data abstraction, which means the separation of data types, logical properties from its implementation. So we have a logical properties, a logical view of data. Also, we can implement in computer. The questions are, what are the possible values? What operations will be needed for those data? Implementation questions, how can this be done in C++? How can data types be used? Object-oriented programming, data encapsulation is one of the important concepts. It is the separation of the representation of data from the applications that use the data at a logical level or logical view. A programming language feature that enforces information hiding for the programmers or users. You can see in C or C++, application point of view, integer y is declared and the value of y is set to 25. Representation case in machine computer, we can using the binary, right? So yeah, like the 16-bit binary integer you can implement. So encapsulated C++ data type int. So data type int, this is data. The value range is integer min, integer max, minimum value of integer, maximum value of integer. If this is a 16-bit case, we have limited numbers of minimum and maximum. Also, possible operations case, okay, the prefix positive number, prefix minus negative number, infix plus minus. This is addition, this is subtraction, this is star means multiplication, slash means division, and this percent means the modulo to get remainder. And also relational operators, okay, such as greater, less, equal, something like that. So those integer is represented in computer using 16-bit 2's complement in binary number system. And the implementation of operations, like those operations can be implemented in the machine level using machine code or assembly code. Abstract data type, ADT. This is a data type whose properties, it is called the domain, and operations are specified independently of any particular implementation. So this figure shows a collection of data in different ways. The first one is you can see textbook 3, 2, or 1 to 3, right? 3 kinds of textbook intermixed on the desk. But here, according to the title, the alphabetical order, we can sorting like that. The third one is we can categorize computer science textbook, mathematics textbook, biology literature book. So ordered by subject. Data from 3 different levels: application level and logical level, implementation level. Application or user level is modeling, real-life data in a specific context. And logical abstract data type level abstract view of the domain. Domain is a property or data and operations. That is called also method. Eventually, this is what core of data. Implementation level case, a specific representation of the structure to hold the data items and the coding for operations like the 16-bit to the complement for integer. This one is actually the how to implement data. This figure shows communication between the application level and implementation level. So you can see this is application user, okay? So it asked something, textbook, and then this librarian gives something, but he check in the book late and then the fine slip, and then he needed to pay for the fine. And this librarian the organized textbook, okay, according to categories. And the other one is programmer for application. This is a utility, low-level programmer, right? So application level programmer just using API, application programming interface. The low-level handled by utility programmers. Okay. So the viewing a library from 3 different levels. Application or user level is a Library of Congress or Baltimore County Public Library in the United States. And logical or ADT, abstract data type level, is that domain is a collection of books. Operations include check book out, check book in, pay fine, reserve a book. Check out case, we can borrow and then we can check in it, return to the book to library. And the implementation view is the representation of the structure to hold the books and the coding for implementation operation specifically. So we have simple data type. On the other hand, we have a composite data type. In C case, structure and the union. C++ case, class. A composite data type is a type which first of all stores a collection of individual data components. They are heterogeneous under one variable name. And secondly, allows the individual data component to be accessed. So for basic kinds of ADT, abstract data type operations, constructor, transformer, observer, iterator. Constructor creates a new instance. Okay, learning instance is called the object of an ADT. Transformer changes the state of one or more of the data values of an instance object in data. Observer allows us to observe the state of one or more of the data values without changing them. It is a kind of constant function or method. Iterator allows us to process all the components in a data structure sequentially. This is the data processor. So two forms of composite data types. One is unstructured. The second one is structured. So unstructured case, components are not organized with respect to one another, like the heterogeneous the member variables are embedded in a data type. Like in C and C++, right? Class is for C++ and the struct for C. And structured case, the organization determines a method used to access individual data components like the arrays. Array case component, array items are almost all the same. It is called homogeneous data type. But classes and the structure case heterogeneous because the members are not the same type. So C++ built-in data type, simple and composite. Okay, simple case, integer type, character, sort, integer, long integer, enum, enumeration, plotting number, real number, plot double, long double. Composite case, array. This is heterogeneous, homogeneous data, right? So previously structured data. And the struct union classes those are the unstructured, okay, heterogeneous data. And also address, C or C++, the address two kinds of C, pointer and reference. Pointer, this one is point the address of the variable. A reference is a new feature for C++. This is similar to point, but different usage. The record is a composite data type made up of a finite collection of not necessarily homogeneous elements called members of fields. So, okay, records means a structure or class in C++. So this car data type case at base address is 6,000, okay, and that the field, the members, year, maker, price, okay, the car, year, car maker, and price of a car. So the type different. This is integer, this is character string, and the price is a floating number. So car type structure, the year integer type, maker is a character array, and price is a floating number. And then this is a okay, declaration. Okay, this is structure definition, and then we declare okay car type variables. This car, my car. Okay, so this is a generation of instance of variable. Okay, this is just a structure type definition. Accessing structure members case, we using period operator. It is called the member selection operator. Okay, for example, the my car is my variable, right? So in that case, my car, the members year here, this one, accessed using this dot period. Okay, member selection operator used. So this operator is used between the variable name and the member identifier to access individual members of a record, the structure or class type variable. And also this class is okay declared here, and then maker second member can access the okay. Also this one is fifth. Okay, remember the C++ array index start the 0, 0, 1, 2, 3, 4. That's why this 4 indicate the fifth okay item in array. Valid struct operations. Operations are valid on an entire struct type variable. Assignment to another struct variable of the same type. Pass as a parameter to a function, either by call by value or call by reference. We will see the difference. Return as the value of a function. So pass by value or call by value. So calling block in the function call, and then the called function. So at that time parameter is copied. Okay, actual parameter copy, contents delivered. So the actual parameter cannot be changed this within this function. So after return, okay, there is no change. But call by reference, pass by reference case, the address of the actual parameter delivered, and then we can change the value because the address indicate the location of variable. That value can be updated after calling this function. Variable can be changed, so can change the value of actual parameter. Okay, using a struct type reference parameter here, new future C++ to change member, okay, value. So adjust for population, car type, car, plot the percent. Okay, so this function increases the price by the amount specified in percent. Okay, so car member variable price multiplied by this parameter, okay, cent, and the car price. Okay, also this is increase one, this is original one, and then car dot the price value is updated by this, okay, increase. Okay, so we are using the reference. Okay, so the cars, the original, the value also updated like that. The sample code adjust for inflation my car 0.03, and then using struct type value parameter to examine a member. Okay, so the boolean is true or false type. Late model car type car in date. Okay, so returns true if the car model year is later than or equal to date. Returns false otherwise. Okay, so the car year is greater than equal date case. This one is okay, this is equal, or this one is less. Okay, so this is new car, right? So if this year is date is this new car or new old car, but this late car case, the car model year, this is later, which means later. Okay, later is greater than equal. Okay, or equal case, this late model, recent model. Okay, return otherwise or old model. So my car, so if late model, this boolean function my car 1995, and then if this is true, okay, my car, yeah, value is printed using standard IO stream. Okay, and then line P is print out. Okay, let's move on. Array, one-dimensional array at the logical view, logical level. A one-dimensional array is a structured composite data type made up of a finite fixed size known at compile time. Collection of homogeneous, which means that all items are the same, all of the same data type elements having relative positions from the beginning of array and to which there is direct access. So any item can be accessed immediately because of the position can be easily calculated because of homogeneous, okay, the character of array. Any array operations such as creation, storing a value, retrieving a value are performed using a declaration and indexes. So implementation example, so this accessing function gives a position of values array index. So array the item according to index, we can calculate that. Address index is base address is the beginning, the start address of array. Index multiplied by each item in array. For example, plotting values of 5 case. So starting, okay, address is 7,000, and then the each item plotting is 32-bit, which means 4 bytes. Remember, 1 byte is 8-bit. 4 times 8 is 32-bit. Okay, so array index, remember, start from 0. Okay, value is 0, value is 1, 2, 3, 4. Okay, so we can calculate this base address plus the index. This is 0 case, this 1 case, this 2 is this, 3, 4. Okay. So one-dimensional arrays in C++, the index must be of an integral type, symbol type, character, sort, integer, long integer, or enum, enumeration type. The index range is always 0 through the array size -1. Arrays cannot be assigned one to another and cannot be the return type of a function, okay? Because they fixed the data type. Another example, this accessing function gives the position of name index, okay? Okay, so address index of array, base address plus index multiplied by size of array element. So character, array case, character size is 1 byte, okay? So base address is 6,000. We have 10, so 0, 1 to up to 9, 10 items. So array we can index name 0, name 1, name 2, blah blah blah. Name 9 is the last item of array name. So each cell can contain one character. So the passing arrays as parameters in C++, arrays are always passed by reference. So this reference operator, ambassador is not used with the former parameter type. Whenever an array is passed as a parameter, its base address is sent to the call the function. So call the function using this array address to operate data in array. Const array parameter. So this one case we cannot change the array value because arrays are always passed as reference parameters. You can protect the actual parameter from unintentional changes by using const in a former parameter list and function prototype. Okay, so we can passing this array. Okay, so in that case we can using array values, okay, rather than change of array values, and then number of values. Okay, so values are here. So values 0 through values the number of array, number of values -1 is maximum array item have been assigned. Okay, return the sum of the value 0 through this value. So okay, we iterate. The sum is set to 0 initialized, and the index 0 up to index less than this one is iterate the number of values. The index change from 0 up to num of values -1, right? And then a value initially 0 and the sum is 0, right? The sum value. And then secondly, this condition, right? So index less, right? And then we can iterate again until index becomes a num of values -1. We can perform and then exit, because this is equal case exit. So we return the value of a sum. Let's move on. Two-dimensional array at the logical level. A two-dimensional array is a structured composite data type made up of a finite pixel-size collection of homogeneous elements having relative positions and to which there is direct access. We can see example later. Array operations such as creation, storing a value, retrieving, access a value are performed using a declaration, and a pair of indices called row and the column indices representing the component position. Row and column is crossing, means the location of two-dimensional array item. So this is two-dimensional. Okay, so this is a row index, this is column index, okay, in matrix. So array two-dimensional array is a matrix. two-dimensional matrix. The example to keep monthly high temperatures for 5 states in a two-dimensional array. So 0, 1 up to 45 is okay. 50 states in the United States. And then this is column is the month's temperature. 0, 1 to up to 11. 0 is January, 1 is February, and 11 is November. So this temperature, okay. So okay, now num stage is 50 constant integer and num months 12 constant integer. In that case, we cannot change the value of this num stage, the variable num months, because declare constant integer. And then we declare two-dimensional array state the height. Okay, the first one is the index for state. The second index is index for months. The finding the average high temperature for Arizona. Okay, so Arizona case, the low is 2 and the column so low, right? So we iterate this. Okay, so we pick this one and iterate this column index, and then we can find the greatest number. So total and month average, right? So month is 0 up to num months is 12, right? 12, and then increases and the total, and then the average first, right? So and the state the high 2 is picked because this is picked. These columns, the item we can sum up, and then we can average 12 divided by the 12. Okay, remember this is temperature is integer and the divide by number is integer case. Maybe if is case we need kind of conversion for floating number case, we intentionally use 12.0, and then this number, this rational number will be the floating number, and then plus 0.5. Okay, and then we can get the average value. Okay, so the 0.5 is a kind of some the compensation value. Okay, and then so story point of view, so storage case is a kind of one-dimensional. So two-dimensional case we emulate two-dimensional using one-dimensional memory array. So this is memory. So each cell contains one integer number. So array, this two-dimensional array base address is 1000. Okay, so the first two is stored here, the second state here, stored something like that. Okay, we can group like that. So implementation low level case, the base address, and then you can see the cell. Okay, the first 0 means the first state, and then the second index is 12 months temperature, right? So we can calculate like this. Okay, so 12 groups are allocated. So locate an element such as state 2 and 7 case, the compiler needs to know that there are 12 columns in this two-dimensional array, and then calculate the location. The at what address will state the high 2 and 7 be found. Okay, assume 2 bytes for type integer. Okay, but actual usual type is integer, is 4 bytes. Okay, another example, two-dimensional object is a map. Okay, so this is a map. Okay, so we can make the grid, right? So we can make the region using row index and the column index. So two-dimensional array parameters. Just as with a one-dimensional array, when a 2 or higher 3 and 4-dimensional array is passed as a parameter, the base address of the actual array is sent to the function. The size of all dimensions except the first must be included in the function heading and the prototype. The sizes of those dimensions for the former parameter must be exactly the same as in the actual array. Okay, here use the two-dimensional state height array to fill a one-dimensional state array here. So Alaska, Arizona, something like that. Okay, so this we declare. So to find the arrays, we can implement the function. So the state, the high, this one is this array, okay, and the number, okay. So this indicates actual the array, okay. So usually array case don't need to specify the one-dimensional case. We don't need to specify the range of first dimension, but two-dimensional case, second index maximum should be specified. The compiler can calculate, okay, like the blocking. Yeah, we saw this blocks we can calculate. Without this second, the index maximum value, compiler cannot figure out. And then state average we can calculate, okay. So pre condition state the highs, okay, this two-dimensional, okay, array input, and the post condition state average is okay. So we want to calculate, okay. So state average case just one-dimensional because we have a 50 states, right? And contains rounded high temperature for each state in the United States, and state months and total, and the state we have maximum 50, okay, in the total, and then each state, okay, state index start at 0 up to num state minus, right? And then we can calculate the total, and then we after this the for loop we can calculate the average, okay. And so 12.0 to make this total slash means divided by 12, okay, 0.0, we make a floating point number and compensate 0.5 using a type def with arrays. The helps eliminate the chances of size mismatches between former and actual parameter. Former is a definition. This is for function definition, and this the actual parameter means we can say the argument is a calling of the function. So for example, so type def int state high, this one we can using type def, and the state high type is two-dimensional using this range of state, the range of months, and the state average case we can type def. This one is array, one-dimensional array. After find averages, okay, we can call constant state height this time, state average this time, like the simple unit, right? But this is array, okay. And then declaring multi-dimensional arrays, okay. So multi-dimensional, this one is department, this, and the number of months, this stores, okay. And then we can also three-dimensional, we can this is department stores, okay. So the monthly sales type, and then we type def, and then this monthly sales type is three-dimensional, okay, the array, and then we can declare one variable, array variable, monthly sales. And then we can see departments, number of departments. Okay, 5. This is the number of mensos, the number of stores. Okay, and then type def. Okay, 3-dimensional, and then we vary. So we can make a 3-dimensional. Okay, so 2 and dimensional, also multiple, a kind of a cube model. Okay, so month is 3. This is okay. Department is 3, and month is 7, and the store is 0. Okay, 0, 1. Okay. Okay, let's move on. A little more complex. Okay, ADT. Composite data type is C++ class data type. A class is an unstructured type that encapsulates a fixed number of data components, such as data members, with the functions called member functions or member methods that manipulate them, the member variables. The predefined operations on an instance of a class are whole assignment and component access. So this figure shows class data type specification. So class, we can define class type. So public and the private. Public is outside the function can access this object generated by this class. The function can be accessed, called, by outside this class. And the private is other object or function cannot access directly. So we allow access of this property using its member functions. So initial is initialization function, member variables using these parameters, and get year, get month, get data just return the member variables value. And then here must be here semicolon here, like a structure definition. Okay, the use of a C++ data type class. Variables of a class type are called objects or instances of that particular class, and software that declares and uses objects of the class is called a client. Client code uses public member functions called methods in object-oriented programming to handle each class object member variables. Means calling a public member function. Okay, this is a client code using data type. So main function include data type. We declared this data type, and then namespace is a standard library. Standard. So using namespace. Namespace we discuss later. So the function name is specified. Specified this standard. Package. And main function we declare two function the variables start date, end date, and then boolean retired. Initially we can set false, and start date initialize function is called to initialize its member variable start date and end date in the same way. So 1998, this was June 30. This end date is 2002 October 31. So we print out start date months is, and start date days is, and start years. And then the retired is false, not means true, right? So finish some task here. To separate the files generally used for class type. So .h and .cpp or .cc. Windows case extension for implementation of class is .cpp, but Linux case we are using .cc. So we define class data type, and we actually call and implement the member variables or the member functions. Okay, member variables are handled by these member functions. So data type class instant diagram start and the date. So member functions called the method public can be used out of this class, and the private data cannot be accessed by other object. And this and the date object. Okay, the methods start the date and the date are the same, but private data start the date and date different because the initialization parameters are different values. Okay, and then implementation of a data type member functions. Okay, so data type H we include, right? Include the definition of a class data type, and then data type.cpp we call initialize. This one is a class, and this is a class identifier. This is a specifier. Okay, and then data type function initialize the code. Okay, this one, and then year, month, day are set using parameter past the values, and then the get month constant k just return value, not change the value of class variable. Okay, and get year return year, and get date day, and day returned. Familiar class instances and the member functions. The member selection operator dot. This one also used by structure in C case. This one is used. Okay, so selects either data members or member functions. Okay, the header files IO stream, input output stream, and the upstream file stream declare the input stream, O stream, output stream, and the input file stream, OF stream, output file stream, IO classes. The both CIN, this is input stream. Okay, this operate object, and cout is standard output class object. Okay, and get ignore are member functions, right? So cin get, cin ignore can call its own member functions. These statements declare my in a file as an instance of class if stream and invoke member function often. So we can using this if stream. So in order to we input from file named my data date, we can often using if stream this object, and the member function call often is called. Okay, parameter is a file name. So we have a scope resolution operator colon. Okay, it is a scope resolution operator. C++ programs typically use several class types. Different classes can have member functions with the same identifier like light. Member selection operator, dot here, is used to determine the class whose member function light is invoked. Okay, so you can see a current date, numbers, right to right. So specific object function. Also the type different, right? This current date is class is data type. This right is complex number type member function. So this information are different. In the implementation of file, the scope resolution operator. This is scope resolution operator. Left hand side is class, right hand side is a member function. This is used in the heading before the member function's name to specify each class. Okay, so this member function, the before this scope resolution operator, this is the class name. Okay, let's move on. Inheritance. Okay, so we can define vehicle, and then the wheeled vehicle can construct the existing vehicle class. This one is good for code reuse. Also the safety, because the base class or parent class is already tested, and then inherited class case we can easily develop, because most of the variable function are verified in advance. Okay, and then we can here vehicle and bicycle, we can make the object using wheeled vehicle, and other vehicle is a boat. A short view of object-oriented programming, three interrelated constructs are used: classes, objects, and inheritance. Objects are the basic runtime entities or elements in an object-oriented system. A class defines the structure of each object, having member functions, code, also a method, right? So but it has member variables. Okay, and the classes are organized in an is a hierarchy defined inheritance like this. Okay, vehicle, so wheeled vehicle is a child of the vehicle, so this is called the is hierarchy. Okay, defined by inheritance. So inheritance, two things we need to remember. First, allows the programmer to create a new class that is a specialization of an existing class. Okay, so we can inherit member variables and member function. We can enrich, we can add a new member variable. Also we can overriding means that even though name is the same function, we can make the functionality differently. Okay, secondly, the new class is called a derived class of the existing class. The existing class is called the base class, okay, of the new class. So inheritance fosters support the use of code by allowing an application to take an already tested class I mentioned before and derive a class from it that inherits the properties, member variables the application needs. Okay. Okay, polymorphism is I mentioned the overriding of function such as a parent function and the child class function are named the same, but child class can override, which means the function can be changed, okay, inside of the class. Okay, so polymorphism, the ability of a language to have a duplicate method name, member function's name in an inheritance hierarchy, and to apply the method that is appropriate for the object to which the method is applied. Okay, so we can take a look. So left hand side problem space object and then abstract to classes. Okay, so descriptions object, and here implementation page case, class type definition, and then they're belonging to problem space of object. Okay, so inheritance and the polymorphism combined allow the programmer to build the useful hierarchies of classes that can be reused in different applications. This is called reusability. And then mapping of a problem into a solution, okay, using this kind of figure. So we have now we can define class money type. Okay, so money type initialize dollars R and cents R. Okay, and then those are public. Okay, member functions, and then private member variables are dollars and cents. The type is a long integer, and then this is ext money type. Okay, so extended money type, a public money type. So it inherit the parent class money type public. Okay, so public and private, so public methods and the private member variable. Okay, so here we can declare the class variable using this ext extended money type, and then below this extended ext money type member, this is resolution, this one, mark and initialize. So initialize function, you can see this one code, and then inside also money type, the member variable initialize also called using this kind of scope, resolution, symbol, and then ext money type currency is just return the currency. The next topic is about error handling in C++. Exceptions. An exception is an unusual situation that occurs when the program is running. So exception management case define the error condition, includes code containing possible error using try function, alert the system if error occurs using throw function, and error handler if it is a thrown catch statement. So try, catch, throw, try. So code that contains a possible error, so and then error detected case string such as an error has occurred in function blah 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 is throw is transmitted on catch function, and then catch function received from throw and print out the message delivered by this try this block, and try a catch. So in file and the value is stored, and then from file the value is retrieved into a value is less than 0 means negative value, right? So true, and the catch is code. Otherwise the sum of value performed until the in file has content, and then catch string message is print out. And this one is called continue processing if exception not thrown. If there is no this one is throw not performed, just skip catch, and then this sum of values on the file is print out. Let's move on. Finally, we have namespace. So namespace, MySpace. So all variables and the functions within this block must be accessed using scope resolution operator. This colon, scope resolution operator. The purpose is to avoid the namespace pollution. So 3 ways to access members within a namespace. Qualify. So this one is scope resolution operator, right? So using scope resolution operator, my space name case MySpace variable is referenced. And then using declaration, so using MySpace colon name is all future references to name okay, is report to MySpace, okay, name. Okay, this is a scope resolution operator. And using a directive case, using namespace, okay, MySpace case, all members of MySpace can be referenced without the qualification, like using MySpace, okay, scope resolution operator, this name operator not used, okay, without, yeah, qualification. So, okay, the rules for use of namespace, the standard, okay, within text, qualify names in prototypes and the function definitions. And if name used more than once in a function block, use using declaration. Finally, if more than one name is used from a namespace, use using directive. So you can refer to this, okay, scheme. Okay. So map to Joe's diner. So we have more than one ways, okay, solutions. So you are here. So you take a big highway, move toward to the right, and then Joe's diner. Okay, so restaurant you can arrive at here. On the other hand, you can go this way and detour, and you can go. Okay, but final destination the same, which means the solutions are different, but actual impact result the same. But efficiency point of view, the first way is better, right? Algorithm case also solve the problem different ways, but we need to figure out the the fast algorithm, right? So which cost more to feed, right? So elephant and this fish, right? So the elephant, okay, the more cost to feed. So from now we'll discuss the time complexity, the order of magnitude of a function to measure the efficiency of function, the order of magnitude or big O notation or function expresses the computing time of a problem as the term in a function that increases most rapidly relative to the size of the problem, like the input size. So according to input size and then we can get the actual learning time, okay, in terms of algorithm. So names of orders of magnitude, we are using big O notation. So if bounded constant time regardless of input, big O 1. And input size n result, okay, algorithm is log to n case, logarithm time. And input n result time of algorithm is n case, linear time. And this is n times log n time. This is n square quadratic time complexity. And 2 power n, this is exponential time. This is not good because a lot of time is used for the calculating or performing some function. So you can see the top n log n and log n and square to n, right? So increases the number, okay. So like this is 1 2 4 something like that, log the n log n and to power n, right? So if n is 32 case, you can to power n is significantly big number, right? So that's why we try to come up with the n linear time algorithm over logarithm algorithm over n times log. This is still good. N square is reasonable, but you know, to power n is this is worst case, okay, algorithm. So comparison of two algorithm. So you something you can like this way. There is no time to take a copy, but using this kind of simple, arithmetic, you can save time. You can have free time to have a copy. Okay, so right hand side is better. Another example, okay, so find Smith John. Imagine this is your friend name in a person information book, okay? So we have two approach, linear search from, okay, from A and next page, something until you can find. This is a linear search. So we have a binary search case. We can, okay, randomly open and then, last name S and this books, okay, start L, right? So in that case, you can move to randomly, okay, later on, okay? And then, okay, R is still less than, okay, S, right? So later part, right inside, randomly open. But this T and S means T case greater than S, because assuming this name is ascending order in alphabet order, so we move to left portion, right? And then randomly open. So this kind of binary search is log n algorithm rather than n. So bigger comparison of list operation. Unsorted list, sorted, okay. Unsorted case, somehow we need to search, okay, all pages, right? But linear sorted case, ascending order, non-decreasing order case, linear search is we can from beginning to end, right? It takes time n. But binary search case significantly reduced log to n, right? So another get item, put item, delete item case, linear search, binary search, sorted list is good, okay? Especially the binary search time. Searching time is very important. Okay, so we saw the main content. From now on, we briefly see the code and review data type. This data type is namespace is standard, right? So the functions, the scope resolution, okay, case we don't specify scope resolution operator just because standard, okay, class are used, okay, and the relation type is this enum type less, equal, greater, and the data type has this member functions, and then this year, month, year is member variables. So and then we declare the include the header files, also the same namespace standard, and the static. So we cannot change. This is already a kind of global variable, so can accessed by a member function in data type class. So this one month is this January. This is actually initial one, and then this is January. Okay, this is February. So according to the number 1, 2, 3, 4 indicate the months. Okay, number. That's why 0 is not used. And string conversion table case. Okay, this 0 case error, and then 1 is the 31. January, February case, 22 days, right? Something like that. And then initialize the data type. Okay, the parameters are months, day, and year, new values, right? And then the check the range. Okay, the range, the month should be between 1 and 12. Less than 1, greater than 12 is the problem, invalid. Date also, okay, less than 1, also the month, the day. For example, January case, this one, right? January, no, index 1, right? So 31. So greater than this 31, problem, okay? And year case, the year is less than this one is okay, invalid. So we consider at least 1583, okay? And then the functions is get month, return the member variable month, get month as string is conversion table, right? So month, okay, conversion table, month, okay? So month value, and then we can conversion table, the January, this is something, right? String, return, string type, okay? So string type is C++ type. Okay, C case is the character string. This is invented by C++. And then get year, return year, get data, return date. And then relation type, we saw relation type is here, less, equal, greater, right? So compare, okay, a date, okay. So and the a date, year, month, and the day compared. So and then current the object year and the new the past year the value a date compared. Okay, which one is greater or equal or less? And adjust days away. So we add. Okay, so days member. Okay, variable, right? Class, right here, day here. So adjust. So we days, new day, the month, new month, year, new, the finish, right? And then, so if we add the, okay, month is, we check, okay, adjust the month and the year according to the this increasing the days. Okay, so month is February here, and then you know, this is divided by this is modulo 0, modulo 4, divisor is 4, 0, and this is not condition. Okay, this is not 0. Okay, and then this is or, okay, new year, okay, divided by the 400. This condition indicates so month day should be increased by 2024 February case, the number of days is 29, so we can check this kind of special the months for February, check. Okay, and then the new days is less than this month case is true, otherwise we increase months here and also increase months. Instead of that we decrease. Okay, the new day divide minus, okay, this one, this month. Okay, so days in this month. Okay, that is the remaining date, and the month is increased. But the December case, we can add 1. Okay, so divided by this 0, 1 is January. Okay, in that case the month, new month is 1 case, year should be increases by 1. So like this we can adjust. Okay, and then return a date and initialize. Okay, so date, return date, and return. Okay, let's move on. Person type code. So the person type, okay, so initialize, the name is the birth date, and data type we saw previous code review. And then person case name and birth date are important, okay, properties. And then we make new derived class student type from person type. So get status, new function here, there is no get status, initialize. But previous case, 2 parameter argument, right? Parameters, string, data type, but here another string. And additionally we have the status, the member variable defined. Okay, so student case we have 3. Okay, and then the new status here, the third one, new state. And then we can call parent. Okay, so this is a scope resolution operator, right? Initialize this first 2 parameters called. And then get status constant means status return. We cannot change the status value according to the constant member function definition. Okay, so from now on I will explain 2's complement for negative number. So, okay, so binary representations. Okay, 1 bit can be either 0 or 1. just one bit, right? 0 or 1. A voltage value is high or low is 0 or 1, right? High voltage value is 1, low voltage value in computer hardware is 0. So 1 bit can represent two things. 2 bits can represent 4 bits, okay? You can cases 1 bit is 2 cases, another bit is 2 cases. 2 times 2 is 4, right? How many things can 3 bits represent? How many things can 4 bits represent? How many things can 8 bits represent? Okay, you can easily answer it. So binary representation: 1 bit, 2 bit, 3 bit, 4 bit, 5 bit, right? So 1 bit is 0 or 1, 2 bit is 0 0 0 1 1 0 1 1. So 4 cases, 3 case. So we have okay, the base, okay, number. So base is 2, power is the number of bits, right? So 2 power n is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32. So counting with the binary bits. So binary representations, the how many things can n bits represent? The y, so 2 power n, right? Easily, right? So what happens every time you increase the number of bits by 1? Okay, the main topic of this appendix representing negative numbers, okay, negative values, okay. So easy way is using a sign bit, okay. It's called the sign the magnitude number representation, okay. The sign represent the ordering, and the digit represent the magnitude of the number, okay. Sign, okay, if the positive number 0 1 2 3 4 5 6, minus 1 minus 2 are negative number, right? So this is plus sign is omitted, this one, right? However, there is a problem with the sign magnitude represented previously. Can you guess why? The problem is there is a plus 0 and the minus 0 here. This one plus 0 minus 0, which causes unnecessary complexity. So remove this one. Okay, we don't use sign bit, okay, minus plus. So solution is keep all numbers are integer value, okay, binary 0 1 integer, okay, values with half of them representing negative numbers, okay. So let's take a look decimal case using 2 decimal digits, okay, 2 decimal digit. The minimum is 0, maximum is actually 99 because we have 2 digits. So half of them from 0 up to 94, this is a positive number. On the other hand, the 50, 51, blah blah 99 negative, okay. So this positive number, but semantic is 50 is minus 50, 51 is minus 50, 49, blah blah blah, and 97 is minus 3, 92 is minus 2, 99 is 1. The idea is sum this absolute value 99 minus 1 absolute is 1, right? This sum is 100, but 2 digit case 100 is third digit is carry, okay. So that carry is we can overflow out of the 2 bits, right? So eventually 0 0 1 0 0 overflow the 1 bit is we carry is forgot, okay. So 0, the sum is 0, and 92 and absolute value 2 is 100, right? So 2 digit case 1 0 0, the leftmost 1 is forgotten because of 2 spots, right? So and we can say this is 0, right? Which means 99 9 sum is 0, 98 2 sum is 0, okay. So which means the sign are opposite, right? So 94, this one sum is 0. Okay, so to perform addition, add the numbers are discard any carry, right? So new scheme. So signed case 5 minus 6 is okay. Sign the greater magnitude sign is used, right? Minus 1. But new scheme case minus 6 is here. Minus 6 is the 90. Okay, 4, right? 94. So and then we can just sum like a positive number. So in that case minus this is 6, right? So for our case 1 2 3 4 5 this to the right, so 1 2 3 4, right? So in the 99, so 99. Okay, this is minus 1, so we can get minus 1. 99 is minus 1, so 100 is minus 99, the 1, and add the negative sign case negative number, right? Similarly minus 4 6 case, okay, the 6 positive number magnitude is greater than this one, right? 2. So minus 4 is you can see this one 60 96, right? So 96 minus 4, right? 96, and then we can sum means 1 2 3 4 5 6 1 2 3 4 5 6 2, right? Is 2. So you can calculate it like this. Okay, so you can try sign the magnitude and then you can work. Okay, this one you can perform the addition. So a minus b case we can say a plus minus b. So minus b we can have a new value, right? Using this system is called the complement. Okay, so add the negative of the second to the first, right? So minus 5 3, right? So in that case this minus number 9, this one is the sum relationship is plus is 100, right? So this is 95, and this is also converted, this one, and then two numbers, okay, actually negative numbers, right? Sum this one, and then we can get 92 is actually minus 8, right? We can, okay, so this representation called tens complement, which means negative means 2-digit case. Okay, 10. So k is the number of digit. Okay, kind of digit case 10 power k minus the I. So our case 2-digit, right? So 10 power 2 is 100, right? Minus actual number minus number. So this is a tens complement. So based on this idea, we can represent the computer binary negative number. It is called the two's complement scheme. It is for negative values in binary number system without the assigned bit. So this figure, right? So you are familiar, right, with it. So 0 1 2, right? So we can have a 8-bit considered 8-bit. So the 8-bit case, negative case, minus or minus 2, something like that, according to the complement. So you can see this one, right? So now we have base is 2, 2 number of bits is 8. Okay, 2 power 8. Okay, 2 power 8. Okay, 2 power 8 minus 1 is actually this one, right? Minus 1. And so you can see the mirror, the 0 or 1 minus 1 minus 2, right? So the sum is actually 0 because you can 0 0 1 8 and then add this. Okay, left significant bits, 1 1 make carry, and this carry 1 and this carry, eventually all 0 and this nines have carry, but we have 8 bits, we forgot it, 0. Okay, So this is the main idea. So we can come up with the two's complement for negative number. This number case we can do the better way is one's complement. So one's complement case, flip it from 0 to 1, 1 to 0. For example, this 1, right? This 1. So all bits flip to 0, flip to 1, 1 flip to 0. Okay, this is toggled. Okay, and two's complement case just the plus 1. So we can toggle this one, right? Plus 1 is this one. This is two's complement and two's complement, right? So two case you can see 1 1 1 1 1 1 1 0 1, right? And then plus 1 is this one. Okay, so negative number to its complement case. First of all, we can do one's complement and then add the 1. Okay, so addition and subtraction are the same as tens complement arithmetic. This one, so we can tens, right? Convert okay 8-bit number and this one, and then we can get this one. Okay, this is okay, this minus 126, right? This one. So do you notice something interesting about the leftmost bit, right? This leftmost bit. Finally, we have number overflow. So what happens if the computed value onto bit overflow? So for example here, this is actually integer point of view is 120. Okay, 7. Okay, but this is 127 is this one, right? 127 minus 1, right? And then this one, and then we plus actually this is 3. Okay, 3. Okay, so 3 minus okay this one. So the 3 is actually here, right? So we can okay here. So we have this one is minus 1. Okay, and then 3, right? The some case leftmost is overflow. Okay, and the remaining one is this one 2, right? The most significant bit leftmost becomes overflow bit. So this is okay, forgot it. Okay, thus the problem occur when mapping an infinite word on a finite machine, because we have okay 8-bit. Also this one also used for the negative number for binary number system using two's complement. Okay, I think this is good enough for today. If you have a question or comment, please let me know. Thank you for your attention. Bye.